Well, we are in for quite the adventure on this one, everybody, so let's dive in. We have an original Hantarex Polo out of a Mortal Kombat 2. This came with the married tube that it originally was with. It's all one unit, and I gave it a good look over, and everything looked complete. Nothing was missing, so I decided to go ahead and fire it up, and it does nothing. Absolutely, totally nothing, like the fuse is blown. But it's not. The fuse is fine. So I took it off the tube and took a look around, and I found the major problem, but I'll show you that in a moment. But there are a couple of other things we need to show off before we do this. This sat in a warehouse for like 20 years, I think, because it's super filthy. Just super filthy and dirty all along here. We'll clean this when we're done, but it's really nasty. And so the most common issue with these is power supply problems with cracked joints and things. But also here on the side, these resistors here, or the power circuit, this one can be loose, but it's not. This one here is in fact loosey-goosey. And if we look, well, I don't want to show yet. Hold on. We'll show that later. But, so that's one issue. The next issue is this resistor here is a little burned, and that's very common on these, is to have this resistor burn up on you. But it should read around 150 ohms. I think this one burns up and causes brightness problems, if I recall correctly. One of them does, but regardless, should be about 150 ohms. And even though it's a little slightly burned up, we still get 150 ohms. So that's a normal reading. So that resistor is actually okay. Now the one next to it here, let's try and clean this up a bit so we can read what these are. Okay, but I think it's underneath it. R142, is that what that says? 152? I can't tell. But this one here should be about 2.3 ohms or so. This one likes to burn up as well, and it's 2.3. Then, pardon me, the other important resistor to check. So these are the three resistors you always want to check on a Hantarex Polo. This one here should be 150, this one should be 2.3, then one in here should be about 200K. And if we zoom in here, this one likes to burn up as well. And case in point, it's burned up. And it should read around 200 to 210K. And if we read it here, I'll go in this way with this lead and this lead here, we get completely open. Absolutely nothing. Oh well. So that resistor is burned up, and that is common. So whenever you have one of these Hantarex Polos, always check these three resistors, because one of them is probably going to be bad if the chassis is not working properly. It's going to be one of these three. So, man, this is just coated in dirt here. Wow, yikes. Well, we'll get it cleaned up. Don't you worry, little Polo, we'll clean you up. Alright, so those are the only real three big issues I see on the top of this. There's no bulging caps. All the caps are original, but nothing is bulging other than being dirty and having this resistor in here be burned up. That's about the only thing I see visually wrong with it. Now, on the top that is, when we turn this over, someone has changed the flyback, by the way. This is got a sticker on here. It says serviced by P&L. And whenever I see that, I always cringe a bit because they don't do the best work. But it's got a replacement flyback in it. But that's not the main problem we're facing here. The main problem we're facing here is that someone did not like this chassis very much and decided to just either drop something on it or punch it in the face. But it's cracked from here all the way along here. It's cracked across here. It's cracked across here. It's cracked all the way around here, all the way over. It's cracked all the way across this way, like half the board is snapped in half. All the way up here, all the way up this way. So we have a major surgery on our hand here to try and get this working. The bottom of this looks like it's not that bad. I don't see a lot of cracked or broken joints. Nothing is oxidized. Usually it's very important to have a power supply reflow, complete power supply reflow, because these like to get develop bad joints and things, but this all looks fine. Everything looks visually okay, except for the major crack damage. So what we're going to do here, what we're going to attempt, is we're going to attempt to repair all this, and we're going to replace that burned up resistor, and then we're going to just leave it the way that it is and turn it on and see what happens at that point. Because I want to see if it works and what it's doing prior to doing any cap replacement and reflow things like that. That way we know if we do something detrimental, we'll know if we're taking a step backwards or a step forwards. So I'm not going to worry too much about that resistor right now. I need to get one off a donor chassis, and actually I think I have several Polo chassis. Yeah, I got one sitting right here on top of my parts pile over here in the closet. And as you can see, this resistor in here is intact. Actually, all three of these are intact. That's not burned up yet. That one's intact, and that one's intact. It looks like, okay, so this resistor here is R167. This resistor here is R255. And this resistor in here is R. Where does Captain Hook buy his extra hooks? At the secondhand store. Okay, 233, R233, R167, and R255 are the three resistors you always want to inspect whenever you work on these Polos. So those are the main ones. I think R234 in here can burn up sometimes too, but not too often. So if you got brightness issues, I think R167 is the one that likes to burn up. So, but regardless, we've got one here that works. It should read, if memory serves, around 200K. And if we read this one that's not burned up, we get 208K. So, okay, yeah, I think that'll work. So we'll steal that one, but we'll set that aside and do that later. For now, let's look at this loose resistor, and yeah, sure enough, it's right here. So that's bad, and then that one's bad too. So before I forget, I'm going to actually solder that back in before I forget. But while do I have enough? Okay, I got a couple of, so my method, while the iron's heating up there, my method for doing this is we are going to use the fiberglass pen here, spot sanding pen. It's an actual fiberglass pen, not those cheap, crappy ones you get, that say they're a fiberglass pen and they aren't. We're going to use that to kind of bridge all this and put it all back together. Now, how this occurred, I have no clue. I don't know if someone hit it or something fell on it. I do not know. But someone... I almost am tempted to take this flyback out, because I think this flyback got hammered. Because the whole thing is, and then this joint here is completely popped off. Yeah, I'm going to take this flyback out. They forgot to solder in this ground, and I've actually got some I have an original working Polo flyback that we could substitute in here. And not only that, I got a couple brand new ones from the latest batch from Peter at Arcade Parts Repair back in March. So, I mean, I've got, I'll probably put a brand new one. I'll put one of the brand new ones in because we need, I think I need to test those for him still. But I got no shortage of flyback. So I think what we'll do is I'm going to take this out That'll make our job a little bit easier, but I do want to do this before I forget. I'm going to solder this resistor back in. So the most common things to look at is these resistors here on the side for broken, cracked joints, case in point, and then the 3 resistors we talked about already. So, but man, I'm going to turn my fan on here. So if you hear the vibration, actually, you know what? We don't need to mark in the funky bunch that one. Let's just get an actual real fan so you don't feel the vibration. Feel it, feel it. Come on, come on. All right. Now, let's extract this flyback, which I don't even know is working because that resistor's all burned up. I don't have any. No, that was broken. Look at that. That came right off. This whole trace this whole pad is just lifted off of here. So I'll try and save that actually, because we can reuse that. I have no idea how this happened or what happened here. For this to get, oh, that one's broken too. They're all broken. Holy cow, this is crazy. I gotta wonder how things like this happen, because this was in this was not a loose chassis. This was mounted to the monitor, its original factory monitor. It was mounted to it in the frame, so nothing could have got dropped on this so much that it destroyed the board like this with the chassis installed in the frame. That it couldn't have happened without damaging the tube, and the tube is fine. So I don't know how this had to have happened when it was being repaired or worked on, and somebody, another one that's gone, and somebody decided to go ahead and just put this flyback back in like this. It mystifies me how this could happen, but you know, you'd think that if something fell on this and you noticed it, you would try and fix it, but maybe not. I don't know. Okay, so 1, 2, 3, 4, 5 pads that are gone, obliterated. And okay, so those are actually tied to the same trace. All right, these two holes here. That should help, or that should allow us to just lift this out of here. There we go. And I don't even know if this is the right replacement. HR 7191. I'm assuming that it is, but I don't know. But let's just remove it completely here. And this, this is normally the kind you push in with a pin. But there's no hole to push on. There's supposed to be a hole that you push in a pin into and it pops it out, but I guess you just pull it out. Well, so there it is. That's extracted. We'll set that aside for now. And okay, let's see what we're dealing with here. Okay, all this stuff in here appears to be okay. This resistor here looks a bit burned up too. R238, that one looks burned up also. Can't recall that one ever being burned in my past experience, but it reads 10K. I know you can't see it, but that one reads 10K, 9.98. Better than 9.95. Put your body in overdrive. 9.95. If you get that reference, then kudos. So what does it read on one that looks good? 9. Okay, so I guess even though it looks burned up, it reads fine. But the only one that actually needs replaced is the R233 here, the one that's burned up. So I guess you know what we can do is I guess we'll go ahead and just change that. Let's just change it real quick. Since we are here and I've got the other one. Well, if I could find what I did with my braid, here it is. You tried to hide it from me, but I found it. You rapscallions. All right, 233 is going to be this one here. I'm not Jewish, I'm a woman. A woman? No, Roman. So, your father was a woman. Who was he? He was a centurion in the Jerusalem garrison. Really? What was his name? Nautius Maximus. Centurion? Do we have anyone of that name in the castle? Garrison, in the garrison, that's what I meant to say. Well, you sound very sure. Have you checked? No, sir. I think it's a joke, sir. Like Sidiosaurus or Bigus Dickus, sir. What's so funny about Bigus Dickus? Well, it's a joke name, sir. I have a very great friend in Rome called Bigus Dickus. What is all this insolence? You will find yourself in gladiator school, gladiator school, very quickly. With what behavior like that? Can I go now, sir? Wait till Bigus Dickus hears of this. And I was so wrapped up with my Monty Python there that I unsoldered the wrong component. It's actually further back. That's a diode. He has a wife, you know. You know what she's called? She's called Incontinentia. Incontinentia buttocks. Alright, resistor is out, extricated. Let's measure it out of circuit. Wherever it just went off into nowhere land too. There we go. And we're all messed up here. There. Out of circuit, we read completely open. Make sure the leads are good. Yep. Okay. So first casualty here are bad solder pads, all ripped off, broken. Second casualty is R233. That was the only thing we need to replace, right? The other ones all checked with inspec, even though they were a little charred. So I think that was it. So let's grab it out of this one. That was this here. All right. So this is, you know, it's not imperative that you need to keep spare parts on hand like this, because you can always just, I mean, if you don't do this kind of stuff for recreation like I do, then you really don't have any reason or need to keep these kind of parts on hand, like spare chassis and things like that. But over the last 16 years or so of collecting stuff, I got a whole closet full of, there's like 30 different chassis over here in a closet off screen that I just have around for parts, and case in point, it comes in handy sometimes. So now we can put this away. And if you don't have parts, you can just order them like you need to and wait for them to come in and proceed on with your repair. And we'll take this and set this in place. All right, there it is. And oh, you, gosh dang it. Nothing is ever easy. It fell out on me. So we're going to hold it in place. It wants to be difficult, so we'll just hold it in place like that. There we go. Okay. Now, there's one side. There's the other. Let's make sure we get this diode back in. Wait a minute, what is happening here? I am going crazy. I hit the diode instead of the resistor. Okay. Batting 1,000 here, batting 1,000. All right. So we've got our diode back in, resistors back in circuit. Okay, let's measure it, make sure it's 200 and, what, 210? Around 210 or so is what it read. .216, okay. The flyback is removed, so it may read a bit different. And then the other side here we get, oh, it's here. .216, so the resistor is in circuit correctly. That runs around to here, so this should be 216 or so. There we go, and the diode is soldered back in. Let's check to make sure it isn't shorted, and it is not. So we get our 0.5 voltage drop. That's fine. All right, so our resistor's back in. Our resistor is replaced. This resistor is soldered back in place. Everything on the top seems to be intact. Let's reflow our power connector because it's most assuredly needs reflowed. Okay. Oh, yep, it was broken. Hang on, I'll show you. Okay, so I went to reflow that, as you saw, and just like I expected, the AC input, which is absolutely common, had a broken pad. And as I take the solder back off that I added, you can see here, or maybe not. Pad came right off. So you can see right there that it's missing completely. So that right there, ladies and gents, is why I always reflow the AC input header pins on these as well, because they like to crack and break. The traces on this chassis are super duper thin. So I just create a little bridge there, and it does the job. But everything on this power supply side here, all these traces are like super thin, so they crack and break very easily. So part of your inspection process needs to be ignore everything on this side and start by just going through visually, making sure nothing is cracked or broken on the power supply side. So we can do that here, and anything that looks like it might need reflowed, I'll just hit real quick. But otherwise, we'll get this done, and I think that we'll be ready to move on to fixing these cracks. And then see if it works. We might even do a light bulb test. How about that? Does that sound like fun? I know it sounds like fun, doesn't it? Alright, well that all looks okay. I think that'll be fine. Everything else looks okay also. So I think we might be ready to just fix these cracks and then give this a try. After we reinstall the flyback, of course. But we don't need the flyback in to do our light bulb test. But so the HOT resides right here on these 3 pads, and let's just check and make sure it's not shorted or open or something wrong with it. So negative on the center, each leg should be about 0.5 voltage drop, 0.476 and 0.476. So HOT is good. I'm going to reflow it here real quick. And I'm not even going to bother to attempt to do a light bulb test, because the easiest way to do light bulb test is just remove the center pin on the HOT here. So the HOT is this guy right here. And what you can do, the easiest thing to do is just remove the center pin from the HOT out of the circuit, and that will kill the horizontal output. Your flyback won't turn on, you'll have no high voltage, and you can attach your light bulb to the center pin here when it's removed from the circuit to the contact, and that will simulate a load on the system with the light bulb from the tube, and you can do a light bulb test that way on pretty much any chassis that you work on. So okay, with everything kind of preliminarily done, let's fix these cracks, get a flyback in here, possibly do our light bulb test and see if it's any better or worse, because like I say, when I turned this on, this was in the frame and the tube, and I didn't see any of this. So I turned it on, it did absolutely nothing, of course, because all the high voltage lines are cracked like this. So and half of these, and we had 1, 2, 3, 4 flyback pins completely not in the circuit. Even if it wasn't cracked, I don't think it would have worked. So let's get cracking here, no pun intended. And let's start by fixing these things. So let's start with this one. So what we'll do here is we'll use our fiberglass pin to eat away at some of this, so we can eventually reattach our pad. Okay, that should be sufficient, and I'm going to need the trash can here at the ready, because you don't want any of these fiberglass bristles to get in your skin. So I just kind of hang it over the trash can and brush it off into the trash can. So there's that one. Probably just wait till we're all done here, and okay, I think that'll work. We need to verify traces here, so I think that one's broken. because there's a crack right here. I think this one is broken, so we'll fix that. It could be worth investing in a little Dremel, a tiny little drill with a bit on it that I can use to do this without having to go through all these cartridges on these things. But this is just the method that I tend to use and have used it forever. So okay. I think we're cracked along here too. And that can just go right to there. And boy, I tell you. This is going to be fun. So we've got these here. Take this out here. All right, that little detour there, sorry. Okay, now, man, it's cracked all the freaking way over here. So we can bridge this like so, and we can probably just bridge this as well too, like so. So that should work for those, because it's cracked all the way across over to here. As it cracked across this here to here to there. Nope, that's fine. So that appears to be the limit. It looks like it's cracked though. It is cracked across there. Even though it has continuity, it's still cracked a little bit across there. If you look, you can see it's still cracked across there. Yep, right there. So a solder weave will flow, a solder weave will flow. So I think we'll just do one big bridge there. So we got, so that should be all good up to here. I don't have enough of that scraped away. And it should be beneficial, probably could be beneficial to us to use actual pieces of wire to do this, because they might be more secure in the long run, especially over the cracks. See, I can't jump, it won't let me jump the crack, and when I do, it looks terrible. Yeah, we're gonna have to use a component leg or something here, so let's grab a component leg here and we'll do it this way. Okay, I think that'll work. And for a little bit of extra insurance, we will see if we can hit it right here. There we go. Alright, so that should be good. Alright. It looks terrible because it's still got flux all over it, but this down here we can likely just get away without using a, yeah, like that. Okay, that'll work nicely. Okay, same thing here. All right, that'll work nicely. I think it's cracked all the way across here too, right across there. Jeez, man, I'm telling you. Can I jump this? Yes. Successful. Alright, so let's take this kind of at a area by area zone. I think this is cracked across here. You know, we can do a continuity mode. Meter's good, so we go here to here is good, but through, yeah, it's completely, this is cracked across right there. So probably just fix that when we do the flyback pad, but I'll go ahead and tin all that up. There we go. So now we should have continuity from here to here. Hey, all right. I think it's probably cracked from here. So that's good, but up to here, yep, nothing. So we gotta fix this too. That should work. Now if we go from here to here, yay! All right, So systematically, that's going to be taken care of. That's done. That's done. The crack ends right here. We got this crack here. Done. That's fixed. What about around to here? That's good. Down this way is not, because it's cracked right here. Holy cow. Okay, fixed. So, what about this? This looks suspicious, but I think I already checked that. That comes around this way. Yeah, that's fine. It is cracked here a bit, but that's okay. Let's come out a bit. All right. So now we can move on to over here. I should be able to do all these without having to use a jumper. That one's good. That one's good. That one's good. And that one's good. I can hear you screaming in the screen. All right, I can hear you screaming right now. Use jumpers. Well, you don't really need to use them. You know, this is going to be pretty structurally sound the way that it is, without having to use them. But if you want to, you want to see me do it, okay, fine. The dude abides, so there you go. One more. After this one. Okay, I don't want to hear any more complaining now. You happy? Okay. That looks pretty good. And seems secure. Let's make sure our continuity is good. So it looks like from here to here, good. From here to here, good. From here to here, good. Here to here, good. Alright, so then that goes through here. Okay. Okay, there we go. Quick and painless. Now we got to do this here. Probably going to have to go with the jumpers again on these because there's too big of a gap to bridge across there. So let's go ahead and tin those up a bit. All right. It's not soldered down. Okay. One more. Let's make sure that's actually connected. Yep. All right. Okay. Make sure it's not touching the other one. It's not. Okay, so now let's do continuity. Here to here, good. Here to here, good. Oh, that's all sharing the same. Ah. See this here? This trace and this trace are the same. This is all one trace. This one big trace here is connected. So what we could do is possibly, to strengthen this a bit, we can just do this. There we go. I think that'll be better. All right. Let's verify that with our donor chassis. If we grab this one and go like so, this trace here should bring to this to here. Yes, just like this does. There. Okay, I think that's good. Moving right along. What's next here? Got all those. That's fine. So I guess the next step is this big one here. Which that shouldn't be a problem. There we go. That's nice and easy. Now we need to do this whole piece here. Okay, that's easy. And I don't know if these have continuity or anymore. Oh, you stupid bum. There you go. And that's all you'll ever be, a bum. Well, you know what, lady? I don't want to take you or your luggage to the airport. How about that? Alright, so that's all good. We gotta do this. This. That. Okay, that's all good. How far up did it go here? Did it get to here? Nope, that's fine. What about here to here? That's fine. That's fine. We gotta go over here is also bad. Okay, very nice. Don't want to miss this one. Is that everything? I think that might be everything. We got this entire run all the way across here, all the way up to here. Got all that. We got this all the way across here. Now that I see that, I want to, well, that's the HOT. Yeah, we're going to take that out, so I won't do that. Okay. I don't see anything else. We got, this one ends right here. So we got that and this. That's going to get with the flyback. That stops there. But it looks like it might be cracked across here. Ever so slightly. Okay. We got across there. Nothing's there. We got that one. This, nothing's there. Got that one. We're bridged across there. That's good. We got all this over here. This should be good here. Yeah. Well, I think that's it. I think that might be it. It's cracked around here, but that doesn't go anywhere. So that's, I think we're good to go. I took this out because I kept running my hand against it while trying to hold on to this and bend stuff, so I'm going to put this back in now. This is the one that we reflowed already. I don't know what your problem is, buddy, but we're going to bridge you across there. This one is oxidized. There we go. All right, well, I think that's going to be good. Let's grab a flyback and get one installed, and let's think about this. I got that in there. I got that resistor changed. These checked okay. We got our power input header reflowed and fixed. We got our power supply section inspected. I think before we do the flyback, let's take this. Let's do our light bulb test. So here's our light bulb test. We can desolder the center leg of the HOT from the circuit. Okay, now if we look here, the center leg of the HOT is now not in the circuit anymore. We need to verify electrically though. So if we go from the center pad, here's the center pad, here's the pin. Okay, so still connected. So I want to make sure it's not connected. Okay, now it's not. There's the pad, there's the pin. If I push the pin, now it's connected. I let go of the pin, it's not. So right now we are not connected to the HOT. Now, of course, do this with extreme discretion and with a grain of salt, because you can get hurt, but if you follow the steps that I'm doing, you should be okay. So disclaimer. But you can obviously see here, this is a jumper, I think. Yeah, so if we go here to the pad, it's continuity. If we touch the pin, we do not have continuity. So the HOT is now out of the circuit. So we should be able to grab a 60-watt incandescent light bulb, which is the perfect analog to a picture tube. We can take one end and just clip it to the frame like so. The other end we can clip to that leg of the HOT, not the leg, but that trace. Okay, editor Mike here cutting in. It turns out that's not correct. You do have to remove the HOT from the circuit in order to be able to test this and do your light bulb test, but well, you don't have to do that. You can actually lift one leg of TP6, I believe it is. But for this instance, I just removed that leg of the HOT, but I went off on a tangent for like 20 minutes trying to describe and explain the way to do this, but it turns out it's much simpler if we just cut to the point to where I had a eureka moment and realized I've been doing it wrong. I was trying to do it incorrectly and show you the wrong way for about 20 minutes. So you do have to actually either lift the output leg of TP6 or just desolder that center leg of the HOT. Either way will work, but let's just cut to the eureka moment where I realized I was explaining it completely incorrectly, and I'll show you how to do it properly. Okay, so I wonder if we can... Oh, you know what? I think the light bulb test is already documented. Oh, I'm an idiot. I've been wasting your time. B plus is TP6. How you test B plus on the Hantarex Polo is there's a TP6 right here. I think it's TP6. There's a jumper across there. That's where you hook up to test your B plus. I'm a numbskull. I'm an absolute numbskull. Hang on, let me clip onto that, and I bet our light bulb will light up now. No. Oh, yep, there you go. I had a bad connection here. The sockets are loose on the AC. That makes me wonder also. Yeah, we got a bad connection still on the AC input. But look at that. So there you go. Now I wonder if we were to disconnect from that TP6 and go back to my HOT. No. Okay, so my method is flawed here. Okay. Well, so disregard everything I just spent 15-20 minutes here talking about. Let's desolder this capacitor and put it back. Okay, coming off on a really incorrect tangent there. So what we can do here, so the method is still the same. Instead of going to the HOT though, you just go to TP6. Okay. I should have done research, but that's why this is the amateur channel, and you know, we all learn together. So TP6 right here is normally where you test B+. So you have a normal working, let's say you have a normal working Polo, you want to test your B+. Well, you go to the frame for your ground, and then there's a TP6 right here, this jumper. That's where you hook on your actual, whoa, that was fun. I took the light bulb off while I think I still had it powered up. It didn't discharge anything. So, okay, so we'll clip on. So now this should light up if we plug it in, but I think the sockets for the AC input are oxidized because it I had to kind of wiggle it around. I'm going to spray some deoxide in here and plug this in and out a bunch of times here. Okay, let's try that. Now I bet you the light bulb lights up. No? Oh, there it goes. Do we have... I wonder... Oh, that may be normal. I think this goes through a cycle before... That is normal. It goes click, click, on. That's what the Polo normally does. Okay, so that's normal. It's just been so long since I worked on one of these. How do you do a light bulb test? There you go. Take the HOT out of circuit like it always showed. Don't forget that has to be done still. Otherwise it'll try and power up your horizontal circuit and you'll have a bad problem or bad times. But so HOT has to go out of the circuit like I showed, and then just disregard everything after that point and go right to this point. Just fast forward to this. I'll have to do another dedicated video on that. So now, see how we shouldn't have a load on the system anymore. So if we were to ground that out, so I unhooked it before it discharged last time. That's why it sparked on me. But okay, so our power supply section is good. As a matter of fact, now what we can do, since we have it this way, man, I am just all over the place in this video. Sorry about that. We can adjust our B+ now. Actually, you know what? I need to take this cage off of here. Let's take that cage off first, then we can adjust our B+. And memory escapes me as to what it's supposed to read. I'm going to look it up here real quick. Let me hang on a second. Hantarex Polo is supposed to be, I think it's 120. 138. Well, I was close. 138 volts. Fighting this here. Man, what in the heck? There we go. Good Lord. Okay. Okay, now, this is a scatterbrain video for sure, but as long as what's important is getting the information out there, that's all that's important. Okay, so now, with the load on there, we'll turn this on, click, click, boom. Click, click, boom. Now, our B+ pot is right in here, that guy right there. So we need to go to volts DC, and we need to go to ground, and we need to go to here and adjust to 138. Uh-oh. That pot is scratchy. Look at what's happening. Hang on, let's get a little deoxit down in there. And let's go back and forth on that. Back, forth and forth. Wipe it back and forth, back and forth, back and forth. And put it back where it was, right about there. Now let's try this again. Should come back on, hopefully. There it is. And look at that. That is right back where it was, and it's 135. So now we need to adjust this to 138. Ta-da! 138.2. Ladies and gentlemen, we have a functional power supply, and B plus is adjusted properly. So just disregard the last 20 minutes of BS, or 30 minutes. Hell, I don't know how long it was. I went through all that stuff for nothing. But again, you know, that's how we all learn. Now you won't make the same mistake when it's time for you to do this kind of work. So, functional power supply. B plus is adjusted properly. Let's get a flyback in here, get it on tube, get it all hooked back up, and see if our handiwork has yielded any results. I'll get a brand new flyback and put it in here. I have no idea if that other one that we took out is good, but I'm not going to hold my breath on it. So, not sure which of these two holes we're going to have to use. Probably the closest one. That's what she said. And I can't line any of these up. Because I got an inability to see. I'm going to pause here. The video is super long as it is right now. I'm going to pause and come back when I've got this set in place. All right, took a bit of fighting, but I've got it set down in place. So let's see if we can work some magic on getting all this installed. Now, it turns out that I'm not going to end up using this one here because the grounding pin here went into the first hole. It lines up better with the first one, so we're just going to cover all this up like so. Then we can go about soldering this in. So that one's missing, that one's missing, that one's missing. This has a coating on it. Some of these pins on these new flatbacks come with a coating, like it's hard to describe, some type of coating material that's on there, and you have to kind of scrape it away because the solder won't stick otherwise. It can be a bit of a hassle, but okay, that all seems fine there. And that one's missing. Okay, get that off. And now comes the task of trying to put these all back on here. So we'll start with this one. We'll start with this one, I guess. Get on there, there we go. And I should have done this beforehand, but I didn't. And I seem to have lost my fiberglass pen. It has disappeared. Well, no idea where it went. So I'll just break out a new one. It's around here somewhere, but I don't want to spend 40 hours looking for it, so. Okay. Okay. So we need to solder that on there and see if we can somehow create a where is, here it is. All right, we got that. It doesn't look good, but we got it. That should be fine. We'll test it for continuity later. Yeah, it doesn't look good, but it's about whether it works or not, and not what it looks like. Okay, that one was considerably easier. I think this one went here. It did not, but that's okay. We can still use it. We'll just bridge it over. There we go. Looks like garbage, but it works. Now, one more here. I'm just hoping this flyback works, or we're going to have to do all this all over again. There we go. That'll work. And this last one here, I guess we can. This one here has no connection, but I guess just to make it in the for the sense of completion, we can go ahead and just put this one on here, or for the sake of completion. Just to give the appearance of a crappy solder job. And that looks like garbage. I don't like the way this looks at all. But for what it is, it's going to have to work. All right, so let's solder our HOT back in, because nothing will happen with that out. Got it. And give it one last look here. Oh, we got. Oh, glad I did that. Look at this. Did I do that? I don't think I did that. Did I? There's a big bridge across there. I didn't do that. Did I? Don't think so. Possibly. That's why you look over everything, boys and girls, because that right there could have hurt us and we would never have found it. Well, we would have, but it would have been taking a while. All right, well, time to move all this junk out of the way. I don't see any bulging caps. We took care of getting this soldered back in. We took care of the burned up open, was it R233? I think that's what that was. These two that normally burn up, this one's visually black, but it tests good for what it should be. So yeah, and we got our power supply adjusted, working. So we know that's good. HOT was didn't reach shorted. All right, well, I guess that's about it. Let's plug in our G2 wire here. What the heck? What's going on with this? I don't know. So let's just see if we can cut this end off here and just put that directly through the G2 hole and solder it directly in place just like it was before. I realize you can't see because I'm trying to do this with one hand and it probably won't pop through, but because it never does. Nope, the wire just bends. And it's just because I'm too lazy to just use the desoldering braid and open the hole up, but that's all right. There we go, that's through. And we'll add a little mo. Dun 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 dun. Add a little mo. Boom 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 boom. Add a little mo. Boom boom boom. Give me some mo. Boom 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 boom. Give me some mo. Now I guess we can just push this through like the last one. Well, that's all you get on that. Okay. Well, let's look for this. And this. She is all back together. So I think what I'm going to do is just try it the way that it is, and we'll see what happens. Alright, so all hooked back up on the tube. We got our anode, neck, yoke, ground, power, video remote, and I'm not really interested in what the image looks like as long as it turns on and gives me a decent image. I'm not really too worried about, you know, colors and screen size and position and stuff because the caps are all original, but just in case it does come on and turn on and work, I went ahead and hooked up a video signal, so we'll turn that on, and we're ready to test this here. So let's see if it turns on and what happens. 1, 2, 3. Holy crap, it came on. I think the flyback is turned all the way down by default. Yes, so let's turn it up. And it freaking works. Vertical frequency. It freaking works. Holy crap. It freaking works. Where is my contrast? It freaking works. Vertical amp. Hold on, guys. Let me get you on the tripod. Okay. I can't believe it. It freaking works. Where is H amp? Here we go. H amp is the... Whoa. Don't freak out on me here. We got a black bar on this side. Is that... Obviously this could be a cap issue. I don't want to rule that out as a cap issue or flyback problem just yet, but H phase... Oh no, there we go. I had it shifted over too far. Right there. Okay, H position. That's vertical shift. Where is H position? H amp is the width. H phase is the position. Okay, so we need to where, okay, H frequency. No. Why does this is folding over on itself over here? This could just be caps. Like I say, I'm not going to worry too much about it till I cap it and reflow it. Then if we still have this problem, I'll worry about it later. But over here it's folding over on itself. And the odd angle here is because of the frame of this Polo. It's tilted back a little bit. Let me turn this light out, might help. But now I can't see. So, yeah, there's this black bar here. And I'm concerned that this might be a flyback issue. Does it change with the brightness? Not really. What about the screen voltage? Not really. That could just be caps. But look at this, guys. It freaking works. All that work paid off. We didn't miss any cracks. All of our repairs are good. So I think at this point I'm going to take it back off the tube. We're going to cap it, reflow it, give it a little bit more, a better look over, and come back and see if this is still present. And I don't want to. Let's go ahead and turn this off, and I'm going to try an actual PCB just to rule out a possibility with this TPG causing the issue. And let's just throw a Mortal Kombat PCB on it in light of this being from an MK2. Let's see what it does here now. Sorry about that glare there. She's running. There it is. Nope, that black bar is still there, and I'm concerned that it's an issue with the flyback. And we have, we have absolutely no brightness control. Brightness control does nothing. And I know what causes that, and we'll go over that in a bit. But for what it is, it looks pretty good, but we still got this black bar over here, and if memory serves, that's a replacement flyback issue. And worst comes to worst, yeah, I mean it's all cut off over here. Worst comes to worst, I can put the factory flyback in to rule that out. But first thing we need to do is take it back off of here, finish the rebuild, cap it, reflow it, inspect it, all that stuff more. And then I'll go into detail of what causes the no brightness control, and then we'll deal with this last if the caps don't fix it. Alright, so here we have it all rebuilt and ready for testing. So what I found with the no brightness control circuit, so I talked about how I knew already what the problem was, and I was partially correct. There was one more component that I had never seen before go bad that actually tested bad in the circuit. So we'll go over that here shortly, but I got this all back together and we are ready to test it. If it does test and work okay, I am going to put all this stuff back on at a later time. It doesn't need to be on for testing. We are going to test the brightness control. We're going to test to make sure that the left side black bar that we had with this flyback is gone. I'm hoping the caps fix that. So what I did was I did the full cap kit and the full reflow, and I'm hoping that that fixes the black bar. And then in the process of troubleshooting the no brightness control, one of the first things that I noticed was the most common issue is right over here, R240 I believe it is, was completely roasted, toasted, and burnt to a crisp. And so I changed that out with another one supposed to be 180K. 180 kiloohms, and this one that was in the chassis, red, Wide open spaces. All right, so R240 was completely open. That's the most common issue of no brightness control right here, and sure enough, it was roasted and toasted. But then also, C176, this guy right here, C176 resides down in here next to the flyback right there. And this is supposed to be, you know, when you read it in ohms, it should be open, but it reads 5.46 kilo ohm. That's not good. And not only that, it is cracked. I don't know if you'll be able to see it, but it's cracked across here. Dude, one big crack. So this capacitor was faulty. And also, something I've never seen before is C185 was open. Not open, I should say, bad. C185 is bad. C185 resides right down in here. It's this guy right in there. It's a gray one. I changed it out with one from the donor chassis, along with C176. I had a number of capacitors on hand, so I changed that one out. It's this guy right there. So I actually had one of those on hand, but the other one over here, the C185, I did not have one of those on hand. It's 200 nanofarad. I didn't have a 200 nanofarad one on hand, but I did have a 10 nanofarad one on hand, which is what this one was. Anyway, so C185, again, you should read either should read open or in the mega ohm, but this one reads 3.8K. So we had two bad capacitors and a burned up R1 or R240, I believe it is 240. I think it's 240. Yeah, R240. So these three components were bad in the brightness circuit. I didn't find anything else in the entire brightness circuit that was bad, but in my experience, the last time I had this problem, it was C176 was bad, but 240 was okay. In this instance, this was bad and also 240. Now, normally you'd think those are the normal causes, but also C185, which is right in the brightness circuit also, off of a diode in here. In this case, that was bad. I've never had this be bad before, but in this case it was. So I found these three bad components. That should fix our brightness problem. The cap kit and the reflow should fix our black bar problem, hopefully. And yeah, I mean, that's about it. So we'll get this hooked back up and give it a test and see what it does. And again, if everything works the way that it's supposed to, I'm going to put this cage back on and make some adjustments, and we'll see how well it fares. So let's get on a tube and test it and see if this all works out now. Alright, so we're all hooked back up on the tube, ready to check this out. We are hoping for two things to happen here. We're hoping that we now have brightness control. After finding and fixing and replacing, I should say, those three components, we're hoping to get our brightness control back, and we're hoping after the cap kit and the reflow that that black bar on the side of the screen is gone. I've never seen that before. That's an oddity for me. So I'm hoping that it has something to do with the caps or something else going on here. It could have something to do with that C185, because I've never seen that C185 be bad before. Usually it's that 176 and that other resistor or a couple of other components in the brightness circuit, but I've never had to replace that 185 before. So it's going to be quite interesting to see what happens here. So we're hoping to see the brightness control come back, and we're hoping to have that black line gone, and we're also hooked up here to read B+ on TP6 right there. So we're hoping to see 138 or so, but okay, enough talk about this. Let's go ahead and turn this on and see what condition we have now and what, turn that on first, what we have. So here we go, cross our fingers, 1, 2, 3. Ugh, it always takes a minute for the Polo to come on, and we're at 140, so we need to come down a little bit, but black bar is gone. Yes. Not only is the black bar gone, it looks amazing. This looks amazing. No real linearity problems. Horizontal, vertical. Amazing. And the longer this is taking, the more amazing it looks. I cannot believe this. Look how crisp this is. The Polo, when it's working, looks amazing. Okay. Yeah, I mean, not bad. Okay, so our black bar is gone. A little jumpy there. Coming back to life, a little jumpy there. But looks fantastic. We got to jumping a bit. I'm not really going to worry too much because it could just be scratchy pots. Not going to worry about it a little bit. But okay, so our black bar's gone. Now, do we have brightness control? Here we go. Yes, look at that. All the way down, all the way up. Brightness pot down, up. Yes, okay. We'll leave it about there. And boys and girls, that looks phenomenal. It's a bit too green, but I can live with that. Well, now that's interesting. What's this? There's a black bar here. That wasn't there a minute ago. Is it different depending on what's on the screen? There's also a little bit of one here. Look, yeah, look at that. But now that one on the side's not there anymore, and there's one right here. Well, I'm not gonna condemn the Flyback just yet for that, because there could be, see, it's more defined, I guess, depending on what's on the screen. It could be another one of these caps in here that's bad, like this 185. There could be any number of other caps in the circuit that are right on the cusp of going bad that could be causing that. And it's not uncommon for the Polos to have some black lines over here, but yeah, I guess that is kind of concerning, but I'm not going to dive too deep into that because this video is already super long as it is. And yeah, it's more defined, I guess, depending on what's on the screen. But that's totally livable. In the heat of the moment or the heat of the game, you're probably not even going to notice it. And if anything, if I just increase the horizontal size slightly, let's see what we get from that. If we increase the horizontal size slightly, I'll bet you that just goes away. If we increase it slightly here, yeah, now it's completely gone. And that's still just fine. And that line's gone. So yeah, I say that that's fine, and we are lined up in the center with the screen, so horizontal linearity is fantastic. If you do have to adjust it, it's adjusted right. I don't know if I can even show this here. Right here, this little block, right there. That little block there, you spin that little block inside that little assembly, and that will change your horizontal linearity. So, but okay, we have brightness control back. Our black line, our big black blob on the side is gone. The image looks fantastic. We are at 140, so we need to see if we can try to adjust that down to 138, and it's going to be tough here because if you try to reach in here, the tabs here on the color pots have like 160 volts on them, so you want to be careful with that. Now we're at 139. I wonder if I could just tweak this ever so slightly. Yeah, it's there, 138.5. We'll call that good. Okay. And yeah, see, that black bar is not as noticeable depending on what's on the screen. But anyway, okay. Yeah, I think we're good to go now. So 138.5, that's about it. I cannot believe how well this turned out given the circumstance. You can even see part of the crack in the board right there. Given how something must have fallen on this and crushed it and cracked it, and then it got put away, probably at some point for someone to fix in the future, and it turns out that person was me. So given how this was, I cannot believe how well this turned out. Absolutely amazing. So that being said, I'm glad we were able to get this figured out. Hopefully you learned something. I know I did. On every one of these we do, I think I know everything, and I find something else that is new to me. So I appreciate you watching. Thank you very much. Like, share, and subscribe, and we will see you next time.